So for the main feature of software-defined network is that uh, some um, some processes like routing requests, routing flows is no, are solved somewhere in controller or group of controllers who which um, control part of this of the network or network segment for understanding how to transmit data from one point to another point somewhere in the other side of the network. And the main mm, feature is that such division allows us to scale control system, resources for control system. Actually, our course called uh, s- resources for some resources for high-loaded system and telecom system and control system for telecommunication network. It is one of the examples so for high-loaded system and how we can scale. We can change resources for exchange resources for applications not for application change resources for some microservices which is placed somewhere in cloud, and these microservices can solve some problems like routing tasks, finding best paths, some monitoring systems, some uh, filtering or Browser system for some uh, no, some nodes where it is necessary. Therefore, we have opportunity to make telecom network more scalable, more um, scalable. It means we can scale computational resources which is involved for processing. And as we talk, I think we talk about this. Here it's as southbound or the data plane. It's nodes where data is transmitted, and all nodes are supported with control plan using some control plan. It means with protocol open flow, controllers send some information for forwarding tables. So it's routing tables which placed on nodes, and it's by these routing tables, requests or flows of requests are transmitted. Also, OpenFlow protocol is used for collecting some information about the floors, about the state of node and so on. So it helps to manage this node and to um, um, information connect which is necessary information for data which information which we need for data transmitting, we receive from the controller. Also, we have northbound. It means that controller use different uses this correctly. Controller uses different applications, and actually scaling. It's about scaling computational resources for application. We can organize these applications as we need for transmitting, for as we need for fast processing of requests from controller and fast reply. So we can manage time of response from time for response for new flow or some refreshing information for refreshing information on the nodes these processes depend on speed of application work. So how as fast as a controller receive response from application, as fast it will send it to forwarding nodes. So it works. So main idea is transmit data as soon as possible, as fast as possible, and therefore computational resources is influence on the speed of informational speed of the information transmission. Yes. One of the example is Open Daylight controller for LTE. Actually, this picture is not so new. It's maybe 4 years or 5 years, such controllers. But I like this picture because it's lighting the main processes for database, for controller of database. So actually, Open Daylight controller, it's controller for database, database, base station, which not database, base station. So we have base station. Base station is one of the node actually on telecom network, and we have to understand how should be transmitted information. No, actually, the base station has lots of function. Some of this function can be solved in program, no, in controller. So, and this Open Daylight controller, it's open source controller, which was uh, which was developed by different science from different parts of the earth. But what we can see here, we also see southbound API, where is used OpenFlow API, no, OpenFlow protocol. This southbound API, it's some interface with control plane of the controller. So controller southbound southbound API and OpenFlow southbound API. So, what information is present on this interface? First, we have to connect the database, yes, with such services as OpenFlow listener, flow service, routing, and so on, wireless configuration service, because it is controller for wireless connection, so it has wireless configuration service. It has wireless statistic. It means it collects some statistic about flow, about point, and so on and so on. So, as I told you, main for this controller, the main for controllers on telecom networks, main function is routing, and it's lots of algorithm who find the best route and so on. And for best routing, it is necessary to use the best or the latest statistic, because correct routing depends on correct routing depends on correct statistic. So it is statistic for managing, which is collecting for some management processes. Also, we have metric controller. So this metric controller, it's also as neighborhood mapper, its function. It is for something for network optimization. So because we should understand that controller, as it has lots of computational resources, it can solve all tasks what you need and more than you need. Therefore, you can collect some metrics, some neighborhood mapping, some path calculator, some pocket handle, and so on. So it is some features which allows to make good service on base station. What we can see here, what else we can see here? Also, we have this all function is for solving base tasks for controller, and it is neighborhood mapper. No, I told you. And northbound API, it is connected with orchestrated infrastructure, because, as I told, different applications, it's some programs which may be encapsulated into some containers, each is placed somewhere in the cloud and so on, but orchestrator should know where that each node, how often they how many resources it has, is it enough or not, and so on, so on. So it is orchestrator should support all tasks should support all tasks in connected with application on application. What else? We have to forecasting. So we have some function which is organized in the controller from one side. From other side, we have some tasks as statistic collecting for this group of tasks. Different modules inside of controller is used. For example, pocket handler, some statistic manager. It's for statistic. Forecasting, it's for it's function of statistic manager for understanding the how many what node, how many request is it enough or not. All statistic from nodes or from base station if it is necessary collected on this module. And based on this statistic, we can something forecast. According to outside or application, it is some optimizer module, backhaul orchestrator. So it is different nodes who helps who nodes where different task is solved when it is used application. Also, one of the tasks is node connection. It's Pathfinder and OpenFlow plugin. It is network reorganization, this orchestrator and path calculator. So it is different task which is need for transmitted this transmission data from one base station to another base station. Do you have question according to this exactly about this picture? Is it clear? If you don't understand me in English, you can say I can replay. I can explain you in Ukrainian, but I think it is not bad to train English. For me, it's training of my English. Because from time to time I have lecturing in different countries, and so it is necessary to be on the wave. What I want to say about this controller and how it is necessary and so on. Actually, for today, when we look through the documentation for 6G, for next generations technologies, we see that some points says BBU. I don't know, is it okay? Just a few words. BBU. It's I don't remember. It's a transliteration, but it means that it's controller of base station. So because we on the network, next generation network, we will have different nodes, different kinds of nodes. It can be base station, big base station. It can be some small transmitter who just receive and send, and lots of access nodes for access network. And some of them, according to 6th generation white papers, should be um, managed or actually managed by some controller like SDN controller and so on. Therefore, I think this Open Daylight controller is one of solution which allows you to provide new generation telecom, and actually uh, sometimes it seems that technology will never be used and so on because it's some strange technology and so on. But according to software-defined network, um, maybe this technology is not used exactly as independent technology, because for sure we have at Telecom lots of nodes or some networks, telecom networks, where software-defined node network is not used. And to say that uh, all this equipment will be dropped and will after that we will start a software-defined network. No, it is not true. Software-defined nodes or with software-defined networks is nodes are added to the old system. Therefore, in some heterogeneous technology or hybrid network for different kind of of the nodes. But it is as for me, it is really used for, and it is quite necessary to know how it works. One more example of SDN, it is how to use SDN on for security system, on the for securing the node from hacking. And for this, for sure, for this task, we should use some filtering or some activities with pockets. And for this task, for scaling these tasks, we can use cloud technology. Cloud technology is technology of SDN. How it is? For example, we have host A send something bad to, for example, for host C, yes, and this sending is after this node understand that it doesn't know this host or some this information of this request, information of this about this request. It actually information about this request. If it is doesn't know, then this request is sent to controller. It is sent to controller, and then in controller, controller ask application, so used not northbound to no firewall application for some filtering. What this application do? This application send request to parse pocket. Then it is check security policy. Then it is enforce security policy. So according to check security policy, it's ask about on some database, is it correct or not, and it's say not, and then it is parse request, it is sent request to uh, to the controller. Controller receive that request, repeat, and this its answer is such information should be blocked, and therefore it sent uh, it is sent to customer customer to the node that we should block this flow. And that's all. That's all. So for security question, also used controllers because it can help fast and effectively send some requests or solve some problems. One more example is how to when we have some switch, we have some home gateway and the controller is control the work of these nodes and also it says helps to solve some problem. What kind of problem it can help? It can solve the task according to monitoring. This monitoring application has five points. From one side, collect statistics. So it is these points send the start request. From other side, after receiving the start request, this application which is used to send some information to analyze network statistic. Then it is detect attack, enforce floor rules, and so on. Therefore, we have such monitoring application which work with different nodes. It is used some controller for this detection for this monitoring, and controller knows why this controller is necessary, because controller knows what to do with that how to communicate with physical equipment for data transmission. From one side, it's API of southbound. From the other side, it is know how to communicate with application. It's northbound sound. And it is good for uh, for scaling. I always talk here that, for example, 20 years ago, when I start work on these problems, we have lots of ideas how to make do something something good with the network, but we have not enough resources for um, quality monitoring, so we can understand what points of quality is very necessary from one side. From other sides, we have not instruments for monitoring. But now with this with this software-defined network, we have such opportunity to process all as much requests as is possible, as much as is possible. It's maybe the same as I told you, and according to what we have today with networks. Actually, we have wireless network, we have some network architecture, LAN network, local access. We have to think about energy, about optimization, about handover. Lots of tasks should be solved. And why we have what we should do in the future. Yes, as I told, what will happen with Earth, with some how new technology will make future specialists, future people, how it can be. It's actually it is very difficult question because nobody knows what will be the next step exactly on our reality when we have far outside. But what we should understand then in the future, maybe with maybe in the future we will have some uh, such technology when data transmission is data transmission and lots of variants of uh, control plan mechanism. And this control plan mechanism will be used for for finding best solution. And what I want to say, what more I want to say? I want to say we don't know what will be in the future, but we know that if you will if you can make more in the next step, maybe it is guarantee some better results of your life. According to some timelines, networking on 2021 towards softwareization, yes, towards to virtualization, to some automation. So it is system which is already today have some uh, some uh, ознаки, да. Some points from these three: softwareization, virtualization, automation. We have lots of systems which use it. What can be a problem? We will have new requirements for digitalization, for all of this actually, for dynamically changing support and so on. So all this question is not can you answer me how to make networks more programmable? Can you answer me? Maybe you can speak Ukrainian. Do you know how to make networks more programmable? Is it programmable now?
What do you mean by more programmable?
I mean that how spread some applications or some programs or some is used on telecom now. How do you think? Is it how it works today?
Could you explain last part in Ukraine? I mean, like answer for my question in Ukrainian, please.
What?
Yeah, could you explain answer to my question in Ukrainian, please? Because to be honest, I don't understand a bit. Or you can just
Можем. Ви
rephrase
хочете пояснити, що значить програмованість?
Ну, так, в якому сенсі мається на увазі зробити мережу більш програмованою? Тобто
Ну, застосовувати різні програмні програми або це, ну, саме програми для організації мережі. Насправді це застосовується, тому що навіть при тому, що ну, незалежності від того, наскільки обладнання є, наскільки обладнання є новим чи старим, ну так чи інакше, там є програмні модулі, всякі скрипти і так далі, для того, щоб ну, той саме завдання пошуку найкоротшого шляху. Вона ж реалізується не хардвер, не технічними засобами, вона реалізується саме програмними засобами. Тому якби в цьому плані програмованість мереж, вона так чи інакше присутня. Просто питання в тому, як багато задач на це діло покладається, яка частина задач досі вирішується в такому, ну, реалізована в хардвер, в технічних засобах. Я відповіла на ваше запитання? Я, напевно, відповіла і на ваше запитання, і на своє.
Так, мабуть. Тут два в одному одразу.
Да, добре. To be able to make changes by yourself. Саме так. Добре. What else? Hopefully. Actually, we go, no, so it's this path from technologies from just telecom for no, next generation. Actually, it's idea of next generation. We can hear lots of years. I don't know, maybe 15, maybe more years, but each year it's different technology. So it is next generation is something which is not work today, but some point where the old telecom networks moving to. And here you can see this line for what should be. So for example, 5G is nowadays, for sure it's not in Ukraine, but in the some companies is already test 5G technology, and for in different countries it is used. It is already used. Then from other side we can some tasks for industry for zero. Actually, industry 4.0 it's just for it is about how should work machine independent from the people. But nowadays we talk already about 5G, Industry 5.0. It means that this technology which works with technologies which work without people, it's also work with AI, with artificial intelligence. So it's how it should be used, and actually, I think it is time to prepare some lecturing about AI in telecom, but in telecom and so on, because it is not problem. It's usual thing for today. Also, smart grid, some big data, some cyber physical networking, some connected cars. So it's for today. It's not something ununderstandable. It's normal. All these tasks is for make for solving these tasks, networks need to become more programmable and deterministic. So we have to use programs, use applications for solving tasks with big data, for the cyber secure physical networking. So all this, so we have such telecom, maybe not telecom networks. We have such uh, requests from society to transmit more and more, and some of the tasks for the data transmission should be solved and should be programmable for guarantee some quality of service. And for example, as for connected cars, so we have to add applications. We have to add some programs for solving all tasks what we need for good good quality of transmission. According to Professor Anders Kassler, propose such diagram when we have from one side flexibility, from other side we have static. So what we wait from networks and how it should be, what we should, how we should organize network or solve all that problems what we have. So static and flexible, from other side deterministic and elastic, best effort. So it is actually we want to receive the ideal network system who allows us flexible system, understandable system for with guarantee quality QoS guarantee, and all the best. But we want to have flexible and quality guarantee. From other side, internet is static and elastic with best effort. So it's not what we for all that tasks connected with car connection, with big data transmission, and so on. We need flexible and understandable determinism. From other side, we don't have these features with usual internet. From other side, industrial networks can be not necessarily so flexible or so static, but it for sure should be network QoS guarantee. It should make industrial networks need guarantee for QoS. From other side, we have data center networks, which is programmable and best and elastic. And we have SDN who moves us from the internet to data center networks, actually, because we use data center with we use data center for placing controllers, for placing application, and so on. Therefore, it have a big influence into our into our network. So we have such picture. 5G, it's closer to what we have, what we want to have. It is quite flexible, quite QoS guarantee, and SDN also can provide it to move internet to 5G. So we can for such quality points, we have to use software-defined network to make more flexible and more QoS guarantee network. Also, determin.net determinованный internet, deterministic internet. It's deterministic also. It's static, but quality guarantee. So it's also how to so it actually want to have we can talk about it's 5G and actually for 5G 6G, so we want more from that networks. So 5G it's not enough, more flexible and more quality guarantee we can receive or provide with artificial intelligence usage on the system. So it can be, and also it will be. It's something about what I told you about this picture. Actually, if we talk about internet, it's very interesting because lots of grants and grant requests, they are connected with how to what will be next after the internet, how to plan in next generation internet, and so on. It's really very interesting question, how artificial intelligence change the internet, how all other technology will change the internet. So we want to design for simplicity, design network for simplicity, ends up complex and offset. Difficult to involve to support new cases or new uses. Something about industry 4.0, how to bound delay, millions of sensors, how to organize it, how to manage this, manage it. Adaptation limited, costly, and efficiently. We need to replace hardware. We have to initialize or wait for standardization of such things. And also, telecom network is not so easy to change, so it cannot react dynamically to the changes. Therefore, we need to move towards programmable networks. What else? SDN changed the way of the network design, and routing protocols in internet typically depend on manual configuration. Also, it has very low view. What does it mean? It means that I will not read, but I will talk about this. Routing protocols, when it is used on the node in the classic network, it can see only its neighbors and some information if it receives from its neighbors. For example, if some nodes is dropped, so it can be known for all nodes for the all nodes. But so it's very it's not so easy to use this information spreadly to the segment of the system, as I show at the beginning of the lecture. Also, classic network can't dynamically shift traffic. So it's more delay from the detecting problem to don't send me to reorganization of the path and so on. For programmable networks, it's not a problem because we can use controller for solving such problems. No, don't dynamically shift traffic. It's as I said. So just a minute. It's so we want to have programmability, automation, fast reaction to failures, find grained routing decision, and so on. Locally centralized control. We can do all this only using some unlimited or some extremely unlimited computational resources. What does it mean, computational resources? It means that we use some cloud infrastructure or some other infrastructure for processing our request, It is possible to make it. And according to, you should know that data traffic, so flows with the data is not use some cloud system because it's impossible. It is possible just to make to help with management. Management of the system is provided by um, controller or management traffic, some request with for accessing to the network for different tasks. But you should understand, and I think you know that from one side we have two types of traffic of requests which is circulated on. From other side, it is from one side, it is data. What we send. Other side, it is Ukrainian службовый traffic to organize connection between the nodes, to organize some to inform all network about something and about new requests, for example, old requests and so on. Therefore, this traffic can be processed on the data center, and exactly it's traffic to controller, and controller asks some requests for processing. Ask some application, sorry, for processing the request. Each such thing we want to have, and I think we will have it quite soon. So what about software-defined network principle? We have some enabled SDN-enabled switch. This SDN-enabled switch, just enable switch. What is the construction of that switch? That switch is some ports, some flow table. So information from one flow ports sent to flow table, then next. It means that it's not only one routing table, flow table is on the switch, SDN switch. From other side, we have group table, meta table. So it is some table, actually it's routing table also, and this information to these tables, this node received from the controller, and therefore we have some control center, control channel. So channel, it's function, physical function, which provide how to connect ports, or how to connect different floors from one point to another. From other side, we have some less, you see xn, xk. We have not only one controller, we have not only one switch, we have group of them. Also, controller, it is connected with this data plan, with southbound interface. Install flow tables entities and receive some information what it needs. From other side, it's function application. It's northbound, which process all requests which receive from SDN controller. Actually, we have our lecture started a little bit later, therefore I take more time from you. But I think it's main ideas what you should know and how it works with SDN. Maybe I didn't say something. Okay. Main contribution. Actually, it is some protocol. OpenFlow, for example, standardized protocol to abstract and interact with switch. Moves to control plane all devices and makes it programmable. So, which replace some function which was made without program. Now it is all task is divided into programmer can be programming. You can program this task or not. If not, it's something else. If it's something from control plan, you can use programming for this. And the concept for logically centralized control via single entity SDN controller, as we see on the pictures on the previous lecture and today. We shouldn't think that only one controller or save so big networks, and it is just controller is for some segment of the network for provide for helping the request processing. Okay, I think we will talk about all this maybe next time, because we have one more part of the lecture on this mm, conclusion about okay issues. I want to okay, maybe next time. Thank you very much for your listening. We will meet next Thursday. I hope that it will not without changing the time. But I will write you next time, and also I will send the lectures recording. I think okay, lecture recording. Thank you very much. Do you have questions?
Yeah, I have one. Well, I remember when you mentioned about sixth generation of like network, you said some abbreviation like BBU, if I'm
Mm-hmm.
right. Could you write it in chat or like spell it one more time? Because I
Yes, I
was
will show you I will
or
talk
like
about this. Maybe I will come back to this next slide. Oh, not here. Okay. Yes, I will. Um,
write in the chat if
I can, yeah, if you're interested in 6G, I think it's very interesting for all who are interested. I can send you the white book from one of the companies, different large company. They write such their vision of next generation networks, no, or systems, next generation system. And I think it's not on this chat. I send it now to our Telegram. Uh, you can see. I can show you actually if you have time.
yeah, sure.
Just a minute. Uh, ta, 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 ta. Зараз. Maybe I have this, it's document, it's in English, and I translated for my students. No, not I translated, Deeple translated for my students. I sent both of versions for you. So just a minute. Mhm. You can see it's Ukrainian version. Should be just. Ладно, щоб швидше розказати, напевно, треба українською говорити. Дивіться, тут є оця концепція, що ми очікуємо від мережі наступного покоління. Вони поставлять рамку 30-й рік, і тут є цілий набір різних, от, наприклад, еволюція МайМо, мультиплай, масивний МіМо. Це, ця технологія вже використовується, але вона буде модифікуватися, тому що її ефективність, перевірена та доведена. Вона збільшує пропускну здатність радіоканалу. Тобто з цього починається. Тобто пропонують архітектуру розподіленої мережі і говорять про різні фічі, які будуть тут досягатися. Потім на шляху до, там екстремальні та передбачуване QoS. Ми сьогодні говорили з вами про передбачуване QoS. Тобто, що ми очікуємо, якими мають бути показники ефективності прогнозованими, тому що нам потрібно якісь гарантії. І ось ці, верніше так, не нам потрібні, а сервіси, які будуть доставлятися, вони мають критичні показники до якості обслуговування. Ну, якщо машина їде, то вона повинна швидко отримати інформацію. Відповідно, є певні сервіси, які є критичними до якості обслуговування. І, відповідно, передбачуваний QS надзвичайно важливий. Потім ще одним важливим питанням є енергоефективність. Оце енергоефективність. Чому потрібна енергоефективність? Тому що в мережах шостого покоління, я, можливо, ну, ладно. В мережах шостого покоління ми очікуємо, що ну, через 5 років вже всі захочуть говорити по VR. Ну, мається на увазі, ну, пам'ятаєте, можливо, якісь фантастичні фільми, коли там такі візуалізація з там. З космосу, я не пам'ятаю, який це фільм, ну точно, по-моєму, зоряні війни чи щось таке, коли вони говорять з такою стіною, з візуалізацією. Тобто передбачається, що технології будуть готові до того, щоб ну, говорити отак, от, наче з 3D-людиною, от, але для цього потрібно буде надзвичайні потужні ну, пропускні здатності. І тому, от, якщо ми говоримо про канал, тут, е, тут така ситуація. З одного боку, це пристрій телефонний, який повинен прям дуже багато приймати і передавати. З іншого боку, це базові станції, які повинні прям от теж оцей, особливо якщо оптичні мережі, вони якби мають більше пропускні здатності, то радіоканали і ось ці кінцеві пристрої, вони повинні бути максимально енергоефективними. Тому тут ось ця енергоефективність, вона прям на перший план виходить в мережах наступного покоління. Ну, конвергенція земного та неземного мається на увазі, що буде конвергенція з мережами там супутниковими. Ну, вже сьогодні Старлінки прям інтегровані в роботу нашого життя. От. Тобто ось ці різні технології, тобто взагалі конвергенція мереж, це поняття з'явилося вже давно, ну скільки, років 15 точно назад. Конвергенція мереж це коли ви різні технології об'єднуєте в єдину. Тому що ну, різні технології вирішують різні задачі і по-різному ефективні. Тобто, і це спільне використання різних технологій, це і є конвергенція. Вот. І от тут в даному випадку мова йде про конвергенцію земного та неземного земних таких систем. Ну, от штучний інтелект, конвергенція зв'язку та обчислень, це також передбачається, що буде. Використання спектру, тобто для того, щоб передати цей VR, тобто взагалі оця концепція, вона ну, про дуже наступне покоління. Тобто ще 5G не всі впровадили, але ми говоримо про 6. Тому вони, ці технології, ну, повинні передбачати можливість там VR і прочих таких на сьогоднішній день ще більш-менш фантастичних речей, але воно повинно бути нарізка архітектури безпеки, хмара і мережі та пристрої. От. Я просто хоч по поводу BBU, воно можливо якось по-інакшому. Це щось таке список малюнків. Зараз я швиденько продивлюся, що я маю на увазі, і як воно. Тут тенденції, огляд, це ви почитаєте. Просто я хотіла про BBU, це про архітектуру цієї мережі. Ви бачите, тут дуже багато всього, ну так, систематизовано. Тобто, скоріше, навіть не технологічні рішення, а це просто вимоги до тих мереж, які ми очікуємо наступного разу. Тобто, оптимізація, там з архітектурою є. Про BBU я щось. Ну, BBU, я зараз я тоді знайду інше. Це значить я не тут бачу. Часові рамки. – Цікаво. Ладно. Ну, це ж я точно тут бачила зараз. Бачите, набрехала вам. Угу. В этих немає тут його. Бачите, воно якось по-інакше називається. Зараз хвилинку я, щоб вас дезінформувати. Ем, угу. Не тут. Там, зайде. Зараз ще хвилинку повісіть, щоб я дійсно або спростувала, або переконала, що це таке. І зараз. І назва правильна, просто можливо. Зараз я знайду. Зараз. Це просто така стаття.
Ну, ось там я бачив в останній
От,
схемі.
це,
Так,
тепер бачите?
так,
Да.
бачу.
Просто якщо ми говоримо, ну ми про це, мені здається, будемо говорити, що вроді би ще в лекції ще було. Просто справа в тому, що коли ми маємо мережа наступну там 5-6 покоління, 6-го, вона передбачає дуже багато точок доступу. Це конвергенція мереж. Да? І ці точки доступу, от BBU в даному випадку, я ще, можливо, подивлюсь більш сучасну інформацію, ніж ця стаття. От. Але це такий собі контролер базових станцій. Тобто це так само, як оцей Open Daylight контролер, який якби, вирішує частину задач базової станції. Отут він, як він називається зараз? Мгм. Ну, це просто моя стаття, написалась трохи давненько. А, м, м, Зараз хвилинку. BBU Huawei. Мгм. От. Я говорила про це. М, Тут описано, що таке BBU. Це те посилання, яке я прислала. Тобто це такий собі контролер базових станцій, який використовується в мережах наступного покоління. Тобто технологічно, в принципі, базова станція це ж якби якраз таки є той вузол, через який йдуть всі дані. Тому сказати, що повністю віртуалізованою базова станція, вона, напевно, бути не може. Тобто всі функції пуститися в Хомару не можуть, але частина, от ми ще з вами наступного разу будемо говорити про про NFV, Network Function Virtualization, коли частина функцій віртуалізується, тобто виконується десь в хмарі, а частина функцій реалізується от, бачите, це абсолютно конкретні пристрої з абсолютно конкретними характеристиками, і що хід, вихід, що воно робить. От. Ну, таке. Якщо цікаво, подивіться, також я скину те, що ми зараз дивилися з вами про 6G. Тобто погляд у це все погляд у майбутнє. Тому воно абсолютно не факт, що воно саме так буде реалізовано, але певні тенденції, вони так чи інакше, якби практика, вона фільтрує результати того, що наукових досліджень. Тобто спочатку це була просто ідея, а потім від ідеї до конкретних реалізацій і конкретних пристроїв, як ми бачимо. Чи у вас є до мене запитання? Я відповіла на ваше питання?
Так, дякую.
Майстер коротких відповідей. Ну, вибачте.
Ну,
Плюс.
воно цікаво було, дякую.
О, супер. Ну,
Знову.
це тоді не дарма. Добре, тоді я вам надсилаю цю штуку про еволюцію. Це буде, да, зараз надішлю. Все, всім гарного тижня, бережіть себе, будьте в безпеці. Все,
Вам
дякую.
теж
Да,
дякую. До
гарного дня.
побачення.
Дякую.
До
До
побачення.
побачення.